Welcome back, students, back to the UGC lecture series on laser physics under Swayam portal. What I am going to give now is a continuation of important technical engineering applications, engineering aspects of CO2 laser, carbon dioxide laser, not applications. I have already explained that CO2 laser is capable of producing continuous wave of very efficient laser action. I have explained what is the importance of nitrogen gas, carbon dioxide gas and also the helium. Now, what I am showing is the typical, engineers, scientists like us, we keep on changing one after another parameter, try to get the best out of the design. Now, after so many efforts, what has been found is this one. The optimum value for PCO2D is 32 dot millimeter. What it means, let me explain. You must have a laser contained in a very efficient, very hard glass tube or a quartz tube. Quartz tube is very expensive, so we will usually have a borosil or a very good quality glass, that is a common one. You can even have perspex. Then the diameter is about, let us say, 3 millimeter or 4 millimeter. Now, what I am trying to say, if it is about 10 millimeter diameter, that will be about a centimeter, then the best pressure would be 3 torr. Under that condition, it will become 33 torr millimeter, because already I have taken 10 millimeter diameter. So, 3.3 torr pressure of CO2 is optimum. That is what I am trying to bring back to your mind. This is a laser engineering technique, laser engineering result, first thing. Secondly, once this is determined, we have to work for what is the optimum pressure for nitrogen, optimum pressure for helium. Why do we need nitrogen? Nitrogen is the one which will get easily excited and it will not get de-excited, it will be running around back and forth angrily. It is a nitrogen molecule, and during this process it will hit CO2 molecule. So, CO2 molecule goes to the upper laser level. Remember, instead of nitrogen you can use so many other gases also, but they do not work well. Out of this, nitrogen is the most passive. Nitrogen is very passive. This atmosphere where we live has 80% of nitrogen, only about 10% or 18% is oxygen, all 2 to 3% you have so many other gases. If it is the other way, life in earth would not have happened at all, because oxygen is very reactive. If it is the other way, if we have earth with 80% oxygen, just imagine 80% oxygen and about 20% nitrogen, life would not have existed, because oxygen would have oxidized everything. This is what the disaster would have happened. Fortunately, nothing happened. We have the best condition. So, we have 80% nitrogen which pacifies the oxidizing capability of oxygen. In a similar fashion, nitrogen is the most common gases which we all use in a variety of gas lasers to pacify things, at the same time to reproduce excitation. Now, that is first part. Second part is helium is again an inert gas. The most pacifist, we always say, is the stupidest gas. It will not do any reaction at all. It will get hit by everybody and keep quiet. That is a kind of helium. We use variety. I will come back to this one. The typical example, the typical pressure for this one is CO2, nitrogen, helium. The ratio is 1:1:3. We have 3 types of helium, because this will effectively bring down the carbon dioxide molecule from the lower laser level, then it will immediately come down to the ground level. So, the CO2 molecule is available for the next cycle of operation. Okay. Another interesting thing is, why should we have the pressure to be, the diameter of the tube maybe 10 millimeter? I say, why don't I have very big diameter? Yes, I can have, but if I have a very big diameter, the molecule which went to the lower laser level will not collide with the walls. Remember, helium will collide with the laser at the lower laser level and bring down to the ground level, that is one possibility, and substantial number of lower laser level CO2 will collide with the walls and then come down. All the heat will be converted to the given out to the wall. So, what has been found out is, keep the diameter about 10 millimeter, then keep the pressure as 3.3 torr, then multiplication will be 33 torr millimeter, and this pressure ratio is this. Now, is there any other way you can improve the efficiency? Yes, the best way is cool the diameter whole length of the tube using just send ordinary cold water, which can be easily available. You just from the fridge you can take ice and put in cold water. That kind of cold water is sufficient. Even without just run ordinary water at the room temperature, that will remove substantial amount of heat, eventually delivered by nitrogen, eventually delivered by CO2, even delivered even by helium. So, by cooling you can easily improve the efficiency. That is shown up by the typical experimental result. Look at this one. What is given is a helium pressure. There are so many graphs. I am just taking the most important typical one. The helium pressure is given in the x axis, which is in torr. The y axis it shows the inversion density is proportional to the energy that could be delivered as a stimulated emission. That is the main thing. Greater the inversion density, greater the light output, that is all. So, if you look at this one, for example, look at only one point. At 8 torr of helium pressure, if the temperature is 350 K, about 120 degrees C, it will be hot. Yes, it will be very hot. On the other hand, if I go to 30 K would be about 23 degrees C. That is a typical room temperature. Then you can easily see the power increases, the inversion density gets easily doubled up. Inversion density gets doubled up because lower energy level will be practically empty, that is the point. Then if I cool it a little more, 200 K will be just below 0. At that temperature you can very easily get almost 3 times better inversion density, 3 times more power, which is well within the experimental or the engineering skill. So, you can get enormous amount of energy from CO2 laser. So, let us sum up. You need a high discharge tube of typical diameter 10 millimeter, pressure would be about 3 torr, all these are given here, and then you have a gas pressure, nitrogen would be 1 unit, CO2 1 unit, helium 3 unit. Under this condition, you apply a voltage of about 2000 volts, and then you will have a discharge. On all along, if you look at carefully from what has been given, you must have water cooling. You must have a water cooling throughout. This is what is the typical representation of a CW CO2 laser. Now, let us go to the next step. Let us go to pulsed laser. the pulse laser, before I go to the pulse laser, with all this one, people have achieved a CW CO2 laser of 10 kilowatt is the highest CW laser that has been ever achieved from any kind of medium. This is a very, very powerful laser. That's the thing. There are certain other difficulties that also I have pointed out. It has been pointed out by engineers. CO2 laser needs a good quality mirror. Good quality mirror, usually this is something like a germanium, this is or a zinc selenide or alkali halide material. Out of this, alkali halide materials are not very good because they easily get moisture. Alkali halide is NaCl is one such alkali halide. You know, if you leave NaCl outside, it will become soggy because it easily absorbs water. If you have a mirror which absorbs water, the surface will not be so clean, it will produce a lot of headache. So, what is generally preferred is germanium or zinc selenide mirrors with the gold coated mirrors of reflectivity 90%, 0.9, which means 90%. There is something which it is something you should look at what is given. Imagine that I have zinc selenide mirror, all the tube up to this I have complete zinc selenide, then this is 90%, this is 90% mirror. If it is 90% mirror, I will get only 10% of the light output at the best. What is being done is, inside this there will be a small hole which will not reflect light at all, but that is capable of allowing the light stimulate emission going exactly along the axis. So, you will be able to get enormous amount of light output which comes out as a beam of the diameter of about 3 or 4 millimeter diameter. All these are technical detail employed in CW laser action. Now, we pass on to next important achievement. This is the pulsed operation from CO2 laser. This is something very interesting. Since the optical gain for this kind of laser is very high, there is no restriction anywhere. You can keep on building up lot of population in the upper laser level, because the lifetime in the upper laser level is about 100 millisecond. 100 millisecond is almost equivalent to 1 second. A laser with the upper laser level as 1 second is very, very ideal, because we can slowly build up the population version. We do not have to be in a hurry. So, that is very good. On the lower laser level, lifetime is of the order of few nanosecond. That means there is no limitation at all in terms of building up optical gain. Under this kind of condition, they thought, why do not make a very high power pulsed laser action? Then they built in this kind of technology, which I will show you. This is called something called T laser, transverse excited atmospheric laser. What it means is, look at the energy supplying circuit, electrical circuit. You have a long tube which is about 1 meter diameter. You have 2 mirrors, that also you can see. You have an anode, and then you apply a gas through certain input, and there is exhaust also. I mean, there is a way for the gas to go out also. So, it will be running out, gas will be going out, gas will be coming out. So, there will be a continuous flow of CO2. Keep it the pressure of 1 atmosphere, which means very easy. you start with this experiment. When you start with this experiment, you apply a regular rotary pump, keep on running for half an hour, 1 hour, so that all the air is removed out, then start flowing CO2, which is available in a big cylinder in any small town. Now, why I am saying this one? This kind of home built CO2 laser can be built in India even in a small research lab. You do not need much sophistication. Okay. Coming back to this one, you have an anode and then you have a number of pin diodes. They are shown at the top. There are a number of pin diodes all along them. Then you what other things? All other things are high voltage circuits. You apply a high voltage of at the two end, you will have high voltage of typically 10 kV. Then you have a capacitor which stores a lot of energy, and then at certain point of time it just produce a discharge. This is something very typical to Blumlein circuit, but a modified Blum circuit. The Blumlein circuit technology has been already employed in all nitrogen laser and also in most of the excimer lasers. What I am trying to connect up is what has been done in the far ultraviolet. That kind of knowledge and expertise learned from ultraviolet laser. This was used particularly first for nitrogen laser, then for excimer laser. The same thing has been employed in making use of the far infrared laser also. Then you have transverse excitation. This is the geometry. Then what you do, you keep on applying voltage. At certain voltage, there will be a breakdown because the potential at the tip of the electrode, watch out, these are all pointed electrodes. The potential at the tip of the electrode will be very high, such that it produces an intense discharge between the long rod anode and the pointed negative electrode. Then you will have a continuous discharge. This is called transverse excited laser. The excitation is in this direction. I would say electron will run from the top to bottom. Gas is running in this direction. Laser is running in this direction. Third one, the pressure is very high, which is atmospheric pressure. Earlier we were saying the pressure should be about 3 torr, 5 torr, 10 torr. Those things are gone. You can work at regular normal pressure of about 760 torr. So, it is a transversely excited atmospheric pressure laser, and this can give a laser power. All those things are given here at the pressure of about typical pressure of about 600 or 800 torr, which is about atmospheric pressure. You can get enormous amount of energy. Correspondingly, the pulse width also will be changing. So, all these operational parameters, I do not want to go into detail. What is important is this is one of the most successful laser, most calm, most respected laser also. In this case, in all these cases from the beginning up to this, I have been explaining only two types of population inversion techniques. One is electrical discharge, most commonly used or almost exclusively used for a variety of gas lasers. Another one is optical excitation, which are used for liquid lasers like dissolution lasers or solid state lasers. Third one is a current injection, which is used in the semiconductor laser. These are three things and that are commonly used. Now, people have tried another interesting thing is another new methods of producing population inversion. This is called, for example, this is called gas dynamic laser. gas dynamic laser means it is something funny. I'll put the diagram on. Okay. In this case, you will have a big discharge tube. You will have high pressure gases, nitrogen as well as CO2. Then what would happen is, if you have a high pressure, then you allow the gas to pass through a small nozzle. When it passes through a small nozzle, other side it will be cold, because any gas which is at high pressure passes through a small hole and expands, it will do adiabatic expansion. In any adiabatic expansion or any high pressure gas expanding to a low pressure will cool down, will lower the temperature significantly. If you want to know more, just all that you have to do is, today buy 7-Up or Pepsi or whatever it is, just open it very quickly. Then you will see the whole, it will be frothing up. That is not the point. When you touch it, it will become cold, because in a 7-Up or Sprite, the liquid has been kept under high pressure. Because of the high pressure only, you get all the bubbles. That gives a easy feeling. You feel comfortable because you get the gases going inside and relieving you. It will become, it's a kind of producing stimulation. Now, what is important is, any gas which is opened up suddenly will cool down, and this is what is being done. When it is cooling down, the funny point is, the CO2 molecule, most of them will be at the room temperature. Some of them will go down to the lower temperature. That means, the CO2 molecule, most of them will be in the higher energy level, and some of them will be in the lower energy level, and in this case you will be able to, then if you produce 2 mirrors here and there, you can start with spontaneous emission, stimulated emission. You will get a very high laser in this process. This is called gas dynamic laser, because you do not produce optical excitation, electrical excitation, current injection, nothing happens. All that you have to do is keep nitrogen and carbon dioxide at high pressure. One more additional advantage you can do is, keep the nitrogen gas heated up. Apply high temperature to the nitrogen. So, in this left side, nitrogen kicks CO2 at high pressure. So, CO2 is already at high temperature. By pressure as well as by temperature given to nitrogen, then all of them flow down through a small nozzle, go down to low temperature. Then you will have a population inversion between CO2 at upper laser level and practically, and you will have 0 at low temperature. So, population inversion is achieved and you can get a laser action. This is something what they call very novel method. The advantage of this one is, you can have a large volume of gas being repeated over and over again. You can get enormous amount of energy released by this one. But this is an experimental trial, and it has been achieved in certain laboratories also. All this required big size room, because you need a lot of gases at a high pressure, gas expansion, all these things are, you cannot build up in a small laboratory. You need big space and so many sophistication. Eventually, it was not found to be practical. So, after some time, people gave up this one. It is not commercially viable, and it is not being pursued beyond a certain level to my knowledge. What is most common, most successful is CW laser, continuous wave CW laser, exclusively used for material processing, extremely good. Low power CW laser, low power means below 10 watt. This is very good for variety of medical applications, particularly for all kind of skin treatment. Any kind of skin treatment you have, if you have a laser, lesions and hemangiomas, birthmark, if you have certain tattoo, for all of the CO2 laser is very, very efficient and it is very common. This laser is easily built and it is commercially available. For example, CO2 laser, when I wrote this one, was available for $4,000 and the power is about 25 watt. These days, that kind of lasers are available for 1 lakh or 2 lakh of rupees. They are all easily available from as a regular model from China. A lot of dermatologists have bought it, used it, and they have learnt it very quickly. This particular laser is capable of making a dark woman or woman with facial disfigurement, they all can be removed it. Many women have become more beautiful because of CO2 laser. Thank you very much.